what I'm doing is I'm folding the dermis of the skin, and then I'm folding the epidermis of the skin to create the fingerprints. And because there's friction there, we have an extra layer to reduce that friction. And it would make sense because we didn't always have shoes, right? So we had to walk across the earth without shoes, at least at first, and then we had to figure out how to make shoes on earth to be able to continue to walk. So it's all about protection. It acts as a barrier, prevents fluid loss, right? Helps to fight infection. It also, for skin, it's involved with the synthesis of an inactive form of vitamin D. Okay? So epidermis of skin has a huge role. It also produces melanin. So there are cells in there called melanocytes. This is what gives you the brown color of your skin. And we'll talk about that. So now, these aren't the only examples though, right? Because with the simple, you've got squamous, but then you have three others. So I just wanted to compare simple squamous to stratified squamous. Everybody follow? Okay? I'm going to erase that now. Okay? So if we then compare simple cuboidal and columnar to stratified cuboidal, columnar. Well, cuboidal and columnar will be involved with absorption, reabsorption, secretion, and excretion. Okay? The reason being is because in some areas where we have to absorb, like the GI, because our mouths are almost as dirty as our anuses, which means we're all shit eaters, yes? Then that means everything that we put in our mouth has bacteria, right? Which is true, because most of the food, even if you wash it, still has bacteria on it, right? It's just a matter of how much or how little it has, right? You put it in there, you swallow it. When we get down into, so one other place I was mentioning to you, in the mouth, guys, is stratified squamous epithelium. Why? Why would the mouth be like skin?
I mean, you don't want to puncture something while you're eating.
A lot of friction going on there. Everyone agree? You don't notice it, do you? But when you chew, you're not just elevating your mandible. You're doing what?
Using the muscle.
You're using the muscles to shift the mandible on the maxilla. That's how you grind your food. You know what I follow? So to grind it would mean how many times when you guys chew, you bite your lip?
My tongue.
Or your tongue? That's the alignment of your teeth in your mouth. Either you got too many teeth or your mouth is too small. So you need to go get some teeth pulled, go to an orthodontist, and get them repositioned. All right? And even then, you're still going to bite the edges. So you see why? There's lots of friction there. Is there friction when I go to swallow?
Yes.
Does everyone agree when I swallow? Man, especially like in the morning when you first wake up, you go to swallow, and it hurts, doesn't it? It kind of hurts. Like you haven't eaten all day, and then you go to eat something, you go to swallow it, and that initial swallow, it just kind of hurts a little bit when you go to swallow it. Yeah? You know what I'm talking about. So when that food goes down, you got to reduce the friction as it goes down. So sure enough, the lining of the esophagus would also be stratified squamous epithelium. But when I get to the stomach, stomach's job is to secrete, not to absorb much of anything, but to secrete. So sure enough, it's what would you expect? Simple or stratified?
Stratified.
Well, you would expect stratified, but it's simple columnar epithelium in the stomach, in the small intestine, in the large intestine, in the rectum. Everybody hear me? The anus. So about an inch above the anal, insert your finger, about an inch above the ring. And right there, you're going to see a junction point from stratified squamous of the buttocks going up, and that simple columnar going down and meeting, and they call that the anorectal junction. This is why you should not be sticking anything up your bum hole. Because if it's dirty, which more than likely it is, then you're introducing bacteria, right, into an area that is not meant for friction, right, where you're going to expose that simple columnar epithelium to bacteria, and with the insertion, you can split the epithelium. That increases your risk for infection. This is why homosexual behavior of, insertion of penis into someone's, and of course, I don't want to pick on homosexuals, right? Because you got heterosexuals doing the same thing. I'm not judging anybody. That's what puts a smile on your face, right? More power to you, right? But understand, you run the risk of getting an infection the moment you introduce anything into the into that anal junction, because beyond that junction, you're going from stratified to simple. So simple columnar, this is going to be predominantly for both of these. Absorption, reabsorption. What's the difference? What's the difference between absorption versus reabsorption?
To do it a second time.
To do it a second time. First time I did it's called absorption. Second time I did it's called reabsorption.
Mm-hmm.
Also, secretion. What's the difference between secretion and excretion? Inside. So I released it and it's in, or I release it and it's out of the body. You know what I mean? Release it still in the body, release it, now it's outside the body, can't be modified anymore. Okay? Sure enough, guys, the stratified cuboidal columnar will serve the same purpose. Now, I want you guys to think. When we're babies, don't we smell so good? We do. We're designed to do that. Babies are designed to not smell.
Why?
To make you happy.
Well, except for the food.
Because if they smell, you get over that. Because poop smells anyway, right? Right? Their breath doesn't stink even though you don't brush your teeth. Their saliva doesn't stink. Their sweat doesn't stink. You could take a baby out of their sweat and you'd be like, man, I don't know how they do it. Right? Because if I sweat it like that, I smell like grandma's giso. Anybody know what giso is?
Yeah.
No, none of you know. Some of you don't know what giso is. Giso is that famous mix that makes food taste so good but smells so bad. Garlic and onion. And when you fry that garlic and then throw the onion in there, man, that smells like my armpit. Or anybody's armpit for that matter, right? It smells like clothes and armpit, right? Yeah, and it sticks on the clothes.
No, it sticks on the clothes.
It sticks on the clothes, and everybody thinks that it is your armpits, right?
It sticks in your hair.
Everybody thinks it's your armpits. Damn, man. When's the last time you took a shower? Oh, that's not me. That's my grandma's giso. That's the new excuse, right? So all you college students, right? Now you got a new excuse. That's not me. That's my grandma's giso, right? So
why do they smell so good?
so why do they smell so good? Everybody ready? Because their sweat glands are of a basic type that don't produce any protein, just salt and water. But when we hit puberty, then the glands, most of our glands will go from a simple to a stratified cuboidal / columnar. Did everybody hear me? Which glands am I talking about?
Sweat glands?
The funky glands.
Yeah.
The funky sweat glands. Did everybody hear me? The funky sweat glands, which are the ones that produce not just the salt and water, but part of the cell. Who eats cellular products, guys? Bacteria. Do you see why we smell? Because the glands that come online that secrete the salt and the water with a little bit of cell, the bacteria is going to eat. And then sure enough, that's going to produce the smell. So the babies don't have those glands yet. As babies, we have them. They're just dormant. Everybody know what I'm talking about? The gland is dormant. Then when you hit puberty, everything comes online. Yeah? Chest gets broader. Hair starts growing under the armpits. Hair starts growing in the genital region and in the anal region. Yeah? And we use that. They call it Tanner stages of development. So if I see a male or female come in, I'm their pediatrician, I'm sorry, I gotta see you butt naked. You're 12, 13 years old, I gotta see you butt naked. As much as uncomfortable as that may make you feel, I gotta look at you and see, oh, your areolas, females, your breast tissue is still in development, you got a little bit of sparse hair down there, oh, you're Tanner stage 1. Yeah? Tanner stage 4 means you've already reached the end of puberty. Your breast tissue developed out, lots of everywhere, same thing with males. Lots of pubic hair here and here. And you can note the deepening of the voice, the broadening of the chest in males. Understand? So all these are things that happen under hormonal control. So when you look at cuboidal and columnar, guys, you're going to see that the most of it is going to be don't get me wrong, there are going to be places where you'll find columnar or cuboidal. one place in particular that you will definitely find columnar, simple columnar, I have a feeling, is in from the stomach all the way down to rectum. Okay? And the cuboidal, you're going to find it, you'll find it also in glands. So you will find it in gland ducts. Whereas the cuboidal you'll find in glands. You'll also find it in the pancreas, in the they call them the pancreatic acina cells, which are also glandular. Sweat glands, you'll find it, especially babies' sweat glands. Okay, those that are called eccrine sweat glands, or what they call there's eccrine or merocrine, apocrine, and then holocrine. So there's three different types of glands. There's eccrine glands, eccrine or merocrine, which is the same thing. Then you have apocrine and holocrine. And these are different types of glands. Well, these glands, eccrine sweat glands, all they produce is salt, and that's all they secrete, salt and water. That's aerocrine or merocrine, salt and water. So their sweat, what they secrete in sweat is just salt and water. Apocrine, what they secrete in sweat is salt, sodium chloride, water, and a part of the cuboidal cells that made up the gland. Now, these are the ones that come online during puberty. These are the ones that come online during pregnancy. You understand? These are the ones that are going to be stimulated to go from simple to stratified when hormone tells it to do so. You got me, guys? Everybody follow? So where am I going to find cuboidal and columnar predominantly? In glands. I'll also find it in stomach, right? The stratified cuboidal columnars, you're not going to find those anywhere else but in glands. Nowhere else but in glands, guys. Nowhere else but in glands.
Sorry. After the where it says sweat, sodium chloride plus.
So sweat, the eccrine sweat glands are going to produce sodium chloride and water as their component to sweat. The apocrine sweat glands are the ones that are coming online for the first time. They're going to produce sweat, sodium chloride, water. Their sweat is going to include sodium chloride, water, and a part of the cell.
Okay.
That's what that apo means. Apo means a part of the cell. Did everybody see that? I want you to equate APO as a part of the cell. All right? Now, holocrine, if they're secreting sweat, they'll do salt, water, and the whole cell. Means the whole cell is going to be released into the gland. That means it's going to be secreted and ultimately excreted. That means once it's lost by the gland, it's not going to be recovered by the gland. Guys, you got me? The salt, we do. This is important. As you sweat, so when you initial sweat, the initial sweat is hypertonic, means high salt to water concentration. But then continuous sweat is hypotonic. Anybody know why? Why when I first sweat, I got large amounts of salt that are being secreted. But then as time goes on and I continue to sweat, I'm only putting water out and not salt.
Because the body wants to retain
Run out.
Oh, okay, so the body wants to retain the water.
You don't have any more salt.
So you run out of salt.
Well, I was gonna say, what's the word? I forgot the word. But we were learning last class where it has to spread, and then it ran out of ability to spread because it didn't have.
Right. So if that salt leaves the sweat gland, then what happens to my blood and my blood pressure and my blood plasma?
You're
gonna start like having a loss of fluid.
There's less loss of fluid. See? So
The
I can
body
get
wants to retain the fluid.
so I can get catastrophic loss of fluid from blood because of excess loss of salt from sweat. You understand, guys? So your sweat glands are designed to reclaim that salt. It does that through these glands, the columnar, these cuboidal, some of their glands, and their ducts, guys. The ducts, whether they're simple or stratified, the ducts will reclaim the salt over time.
So back through your skin?
What's that?
Back through your skin?
Back through the skin and into the bloodstream. Because to lose too much salt would mean that the blood pressure would drop, and you can't have catastrophic blood loss. Catastrophic blood pressure drop. Because you have to maintain a certain blood pressure. Therefore, you have to maintain a certain amount of electrolytes in the blood.
Serious, silly question, I guess. If you were to go to the ocean, would your body absorb some salt water through that?
So, great question. This is one of the reasons why if you get stuck in the ocean, don't drink the salt water.
Yeah, no, definitely not.
Because if you drink the salt, but now if you go out, again, the skin is what? If the skin was a single layer of cells, then you would have more fluid moving in and out, right? Because the higher salt concentration out of the ocean than inside your body. Well, sure enough, believe it or not, it's very close. The salt concentration in our body is very close to the salt concentration in the ocean, which tells us that we what? That we came from the ocean.
Yeah.
That we evolved from the ocean. So, but if you sit in there for too long, just like anything else, it would affect over time, right? Because water movement is not restricted. What's restricted is the salt movement, because the salt can only move in or out if there's a receptor there, if there's something that allows it to move in or out. All right?
So it doesn't observe.
Not if you're there for a little bit of time, no. But if you go in there for a long period of time, then the excess salt on the outside versus the inside long-term period will cause a flow of fluid out, which would wrinkle the fingers. So this is why if you go into the ocean too long, you'll see your fingers start to get wrinkled. And
That's because of what?
that's because of the salt concentration difference and the water movement.
Does that affect our fingers so we can improve grip in the water?
No. It's just an osmotic response because the salt can't move in or out. Remember, the skin is multiple layers and it's got barriers. So you'd have to sit in the salt water for a very particular amount of time, and then what'll happen is water will move out of those cells and it'll dehydrate the cell. Right? Same thing if you were to drink the salt water, it'll dehydrate you from the inside out. All right? So, what's that?
Just being in the ocean because of the skin.
Over time, yeah. So the longer you're in there, the more likely you are to have issues with. Yeah.
What about absorbing magnesium?
Yeah. So salts, you don't want to start messing around with any kind of salt because any one of the salts can throw an imbalance off, and that can affect the water. So yeah, absolutely. You got to be really careful. And magnesium is a really interesting one because I found out that magnesium acts to compete opposite of calcium in muscle contraction. So this is one of the reasons where if you consume too much magnesium, you can actually cause your heart to stop and your muscles to stop working. So this is where magnesium is such a key role. You got to be careful with how much magnesium you're consuming. And we knew this because some people were like, oh yeah, magnesium will save my heart. So some of these people that had heart problems started taking excess magnesium. Then they showed up in the hospital with bigger problems with their heart. We're like, wait, what are you doing differently? Oh, nothing. I'm just taking my magnesium supplement. And then we realized, oh, wait. Oh, excess magnesium supplement can cause this too. So it's very, very dangerous. Very dangerous.
What's excess?
Very dangerous. What's that?
I take that every day. What's excess? How much?
Oh, so what's excess? Yeah, for each body, for each human, it's different. So that's what makes it that much harder. it makes it that much harder. You had something in the back you want to share with us?
Well, you need like 4 grams.
Yeah.
The level of magnesium you need to even make that possible is you have to try.
It is, and it, believe it or not, it is and it isn't, because sure enough, it only takes a small quantity to throw that imbalance up. It doesn't, believe it or not, it doesn't take a lot. So what happens when you have that 4, right, that you need, and then you take 4, you get that 0.000001 gram. That 0.001 gram can make all the difference at the level of the cell, because the cell doesn't really care about once it's beyond that normal homeostatic balance, the smallest quantity moving into the cell will disrupt the normal electrical, and that's the thing, is that when we're talking about physiologically, when we start talking about movement of sodium and calcium and all this other stuff, we think it's a lot. It's so small amount. And that's why excess magnesium, even if it's a small amount over the normal hemostatic balance, can cause serious issues with the heart. Of course, on the opposite end, if it's too low, same thing. And again, it depends, because some people, their kidneys can handle it, no problem, man, we get rid of it. And it won't ever cause any problems with organs. But then with someone else who doesn't have that quite so perfect kidney, they're coming in and they got serious problems with their heart. So every human is different, guys, and that's what makes this more challenging.
This is random, but my pressure was at 153.92, and I had a nosebleed. Does that really?
Absolutely, man. Hey, when your pressure goes too high, what do you think your capillary is going to do?
It's like straight.
Dilate.
Your capillary, so your artery wants to preserve the capillary. Capillary is so perfect, you want to prevent it from blowing up. So the artery squeezes down, prevents blood from flowing into the capillary. If your blood pressure is too high, you know what's going to happen to the capillary? It's going to pop.
So is it true that I could have had a stroke?
No, you probably had just a higher than normal blood pressure at that time, and it caused that blood vessel to burst. Now, if that would have happened in your brain, whole other issue. Happened in the kidney, whole other issue. Happened in the heart, whole other issue. You're just lucky it happened in the nose. That's why. Yeah. Are there people who get it in the heart? Yeah. Yes. People who get it in the brain, they'll start like the blood accumulation and the iron and the pigments and everything else will cause serious problems with their brain, and they will have issues. So, guys, I want you to take a look at the rest of these epitheliums, right? So the other simples, there's only one more. It's called pseudostratified ciliated columnar epithelium. It's fake. It's fake. It means it looks like it's stratified. Pseudostratified means I look like I'm stratified and I'm really not. I'm really columnar. And then down here, the other one would be transitional. So in total, I'll rewrite them again, but I want you guys to go and write them on your own, right? Simple has squamous, cuboidal, columnar, and pseudostratified. Then stratified has squamous, cuboidal, columnar, and then transitional epithelium, guys. Okay? And then go and look at the connective tissues, because when we meet next week, then we'll start hitting the connective tissues and we'll go over everything else. Any other questions? And start looking at skin too, right? Everybody sign the sign-in sheet?
Wait, do we have to sign the sign?
Oh, no, sign sheet. No, sorry.